Hello, my name's Al-Haji, and today we'll be trying to figure out the critical points of g of x equals x e to negative 3x. We'll also be trying to classify it as either a local maxima, minima, or neither. So the first thing we want to do is find the derivative of x e to the negative 3x. What we want to figure out first is what else can we include within this function, and that would be the product rule. Which is the derivative of x times g plus f times the derivative of g. So f would be x and g would be e to the negative 3x. Now we want to find the derivative of x. So what we'll do is bring down the power of x, which is 1, and that'll be the derivative of x. Now to find g, what we want to do is bring down the negative 3. In front of the e, and still leave the negative 3x up there because this must always remain the same. So the next step is plugging it in to the product rule. So multiply the derivative of x with g, which is e to the negative 3x, plus f, which is x, times the derivative of g, which is negative 3 e to the negative 3x. And that's our derivative right here for the equation. Now, if we are to move forward, and if we really want to figure out what the critical point is, we also have to set this equal to 0. And another thing is, you must also rearrange the x and include it within the 3 to make it easier for us to set the equation to 0 and to solve, to find the critical points. So what we want to do here is, of course, get rid of, well, not get rid of the 1 because it's still there, it's just in secret. Switch that up, and then this will be just negative 3 x to e negative 3x equal to 0. Now what you want to do here is to exclude ex to the negative 3 from the derivatives. So what you're going to have is just 1 minus 3x. There we go. So what we're really doing here is putting the derivatives all in one place, multiplying them with just e of negative 3x equals to 0. So what we want to do here is subtract negative 1 from 0, and then divide by 3x. And in turn, your answer will be 1 over 3. That's going to be your first critical point. Now to figure out your second critical point, you must plug in the x for the function that's been provided. So that's going to be g of x equals 1/3 times e to the negative 3 1/3. There we go. First thing you want to do is work with the exponent. So when you factor this out, what you'll get is 1/3 e to the negative 1. Next thing you want to do is use the negative exponent rule. Which is b negative n equals 1 over b n. So what you want to do is put the e to the negative 1 under the 1. So it's going to be 1 over e. And what you want to do is multiply these two, and you end up with 1 over 3e. And that becomes your second point. So you get your x axis point would be 1 over 3, and your y would be 1 over 3e. Now when you take this equation and plug it into a graph, it will show you that this is the local maxima, depending on the concavity of the graph. It's concave down, so it's going to be maxima instead of a concave up. If you look at the highest point of the maxima, you'll see 0.333, which is 1 over 3, and 0.1226, which is 1 over 3e. And that is how you find the critical point and the local min, max of the equation.